Hello, this is going to be our third lab. This past week we investigated acceleration due to gravity, G, in objects that are in free fall motion. So this lab today we are going to prove that G is 9.8 meters per second squared by collecting some data, the same data we've been collecting. So I'm going to use this tennis ball and these meter sticks to time how long it takes our ball to go these certain displacements. So I've marked out on the wall every 30 centimeters, all the way up into 240 centimeters, right, which is 2.4 meters. Because, of course, we're going to be plotting this data on a position time squared graph to linearize our data and give us our acceleration, just like we did for the previous graph. And because we need the practice, you are also going to be plotting your displacement time graph, your velocity time graph, and your acceleration time graph. And again, I promise we are almost done with all of this graphing business. Okay, so for the objective for this, or the purpose for this lab, is to prove that G is 9.8 meters per second squared. The skills that we're going to be doing for this lab are data collection and graphing analysis. The equipment we are going to use for this is our tennis ball, our meter sticks, and our stopwatch. If you were in class, you'd use a stopwatch, but I'm going to use the video analysis, which is my BF. And that is it. So just like our other labs and our future labs, we are going to be collecting how long it took to go some certain displacement. So I'm going to drop the ball from 30 centimeters. I'm going to do it 4 times. Then in my data table, I'll take the average, and I'll repeat this for all of the heights up to 240 centimeters. I did want to mention that this is in the Y direction, and our initial position is going to be at the certain heights. So for example, like a little bit different from our other labs that we've done so far, is that if your initial position is, say, at 120 centimeters, and my final position is at 0 centimeters, if we're going to the floor, then my displacement is going to be negative. So if my initial position is 120 centimeters, my final position is 0 centimeters, right? My final minus my initial is going to be negative 120 centimeters. Okay, so having said that, I will say it again when we do our data analysis, but our position 0 for this lab is going to be at ground level, and our initial positions are going to be, did I say our ground level is position 0, and our initial positions are going to be whatever height we drop them from. All right, I'm going to start collecting the data. I'm going to drop it 4 times, and then use the video analysis to get me my times for each trial. So, the one last thing, for where I'm placing my ball, because it's got a kind of a larger diameter, I'm going to try and place it from the center of the mass. So I don't want to place it at the top, and I don't want to place it at the bottom. I'm going to try and place it right in the center for my heights. Okay. I just lost track. Okay. 1, 2,